we have done something about rocks. We have started that topic of rocks, and I know many of you have done it. But then there were some who were asking questions which also required, which were more of summative questions, which required knowledge of other topics. Because when you talk about, suppose the question says that what is the influence of igneous rocks on the formation of landforms? Yeah, that question requires one to have covered volcanicity and the influence of volcanicity on what? On landforms. But if you have not yet covered that, then it is such a question would be unfair to ask one such a question. So, but towards the end there, we have some reference or some revision questions that we may be able to go through. Otherwise, we have dealt with rocks, what rocks are, and the quality, and the physical properties of rocks, then the types of rocks. The three types of rocks we had talked of the igneous rocks, which are fire formed. Those ones we have looked at the details. And we had said there are also other two types of rocks, the sedimentary rocks and the metamorphic rocks. Now, if I can go back to where we were last time, I refer to the what? I share the slides. There's this slide that we had last time. Okay. Which has the summary of the various types of the igneous rocks. Just let me review a brief review before we go to the next one, category or type of rocks. Have the volcanic rocks, the hypabyssal or the intermediate rocks, then the plutonic or deep-seated rocks. The plutonic rocks are also referred to as the abyssal rocks, while the intermediate ones are the hypabyssal rocks. Then the ones which are exclusive found at the surface are the volcanic rocks. So these are the ones, some of you may have covered this topic of rocks, could be having them. So this is just some kind of summary. They're categorized in terms of in terms of their position, their location, that is at the surface, not just beneath the surface, and deep underground. And also they may be categorized in terms of their rate of cooling. Those which cool very fast, and those which cool at an average or moderate rate, and those which may cool at a slow rate, especially those which are deep-seated. Then also in terms of their crystal size, which crystal size depends on the rate of cooling. High rate of cooling, the higher the rate of cooling, the smaller the size of the crystals. So, and the examples are they're here. So those examples, ones we had gone through last time, and this is some diagram also to illustrate the formation of abyssal or plutonic, hypabyssal, and volcanic rocks. Assuming this is the surface, looking at the surface here, the material comes from the Earth's interior. The material comes from Earth's interior. So as it comes, it upwells in form of magma, which is molten rock. It may solidify. So this one here, which solidifies deep underground, this is the plutonic or the abyssal rocks. And their size yes, the size of the crystals is big because the rate of cooling is very slow. Then there are those ones where the magma manages to come up, intrude itself through the crust, but before reaching the surface, it solidifies. They solidify there to form hyperbise rocks. So the examples say that we said that the dolerite and the quartz, examples of hyperbise rocks. Then there are those ones which may be extruded, where the magma is extruded onto the surface in form of a volcanic eruption or a lava flow, which then cools and solidifies to form the volcanic rocks. So here we have, these are the surface volcanic rocks. This is also a diagram to summarize the formation of igneous rocks. And these are the classification according to the mineral composition. Whether we talked of the acidic or felsic rocks, the mafic or the basic rocks, and the intermediate rocks. So that was what we covered last time. For those who were not with us, I think that is where we are. And we are going to move to, and before we broke off, because it was quite late to start on a new subtopic. So we are going to look at the what? At sedimentary rocks. Sedimentary rocks. Now, when we talk of sedimentary rocks, those sediments comes from the word sediments. So those rocks are made from sediments. Sediments. So we could say that sedimentary rocks are formed by erosion. You know what rock sediments are? They're formed by erosion, transportation, and deposition. So what happens is that rocks are eroded. First, they may first of all be weathered. They may be weathered to this and on, because the massive rocks may not easily be eroded. So rocks which have weathered, the material is easily, rocks which have weathered material is easily eroded and transported. So when they're transported, there is a point, especially in low-lying areas, where they are deposited. So when they are deposited, they accumulate on top of each other. The ones which were deposited first at the bottom, they accumulate progressively, and under their own weight, the rocks, they deposit. So the sediments are then compacted. Okay, they are compressed, compacted, and consolidated to form sedimentary rocks. You can see here. Sediments are moved from one place to another. Sediments are deposited in layers, with the older ones at the bottom. The layers become compacted and cemented together to form rocks. So the layers are then compacted and cemented together to form rocks. And these rocks are what we refer to as the sedimentary rocks. Those rocks are the ones we refer to as the sedimentary rocks. Okay. Okay. Yeah, some people may be wondering about the volume. Or let me try to see how to. I still don't know whether someone could have tampered with the what. With the is it louder now? Okay, the problem is that on the chat, there are some who are saying the volume is low. Others are saying that theirs is very high. So now, whom do we? refer to. Okay, Mr. At least
Mr.
now.
Sir.
Oh yes, it's okay.
Mr. Sir,
Yes.
the volume is okay. The particular student could be having a challenge, but the volume is okay.
Okay. All right. Thank you very much.
Welcome.
Now let us saying that sedimentary rocks. This is what we're saying, that the sedimentary rocks, the layers become compacted and cemented together to form rocks. Now let us now look at the characteristics. So what are the characteristics of sedimentary rocks? Last time we also looked at the characteristics of igneous rocks. Now these sedimentary rocks. These rocks contain fossils. They are fossilized. So a section of sedimentary rocks are fossilized. They contain fossils. Then, secondly, I could say that they are laid down rocks. So they are laid down in layers, or they are stratified. They are stratified rocks. They are in strata. Then thirdly, they are not crystalline. So there are no crystals involved. If it's sedimentary, they are not what? Crystalline. Then they are unstable rocks, since they are made up of different particles. Unstable means that they can easily be changed to another type of what? Form of rock. Their color is generally dull, and they are not banded or foliated. They are not banded or foliated. Okay, these are some of the characteristics. So can we hear from Jacob Matovu? They raised the hand. I don't know whether it is.
Yeah, Master.
Yes.
Master. Yeah, Master. I just wanted to find as in the meaning of strata, as in you explained
Strata.
about. Yeah, you explained about they are laid in strata. So kindly, I just wanted to find about the meaning of that
strata. Yeah, these are the different what? Layers. The layers. We shall see them with some diagrams there. So that's why I said it's rocks. They're laid down. Rocks are in what? In layers. So layers here, referring to what? Stratified. They are stratified. Then also when we say that they are not banded or foliated, foliations are characteristics of other types of rocks, of sedimentary rocks. There are some kind of lines which could have shown that these rocks were compressed. They were compressed. Okay, then we shall see more about the foliated rocks. So someone is asking about what foliated rocks are. We shall see those are lines, lines on the rocks, which we shall see clearly when we shall be dealing with what? With the metamorphic rocks. Metamorphic rocks are the ones which are banded or foliated. We shall see what are meant by foliated rocks. Now we can see these layers, these lines. You can see these horizontal lines. That is a strata. That is strata. So this is what strata as well. Strata. These layers. So these are landforms. These landforms are made of sedimentary rocks, as you can see there. This is strata, and so on. Now, we are, as you in a O level, we dealt with the types of sedimentary rocks. Basically 3 types of sedimentary rocks, but when we categorize those types may be categorized into 2, basically. So the categories of sedimentary rocks. We have the clastic sedimentary rocks. Clastic sedimentary rocks. And what are these clastic sedimentary rocks? We know they are basically formed as a result of what? They are mechanically formed. So clastic, when we talk of clastic sedimentary rocks, they're basically 2 categories. But generally, when we talk of the types of sedimentary rocks, there are 3 of them. So clastic, these are made of fragments of rocks cemented together. E.g. breccia. Breccia is a what? Is an example of a clear example of a clastic rock. It is, they are generally mechanically formed. I think all those sedimentary rocks, which are formed as a result of sediments being transported and being compressed together to form such kind of material, are clastic rocks. So one is clastic sedimentary rocks. The example is the breccia you can see here. You have seen the rock fragments. This one, the other one, together. Then the other one is then the non-clastic. So the non-clastic ones are the ones which are not mechanically formed. They're either chemically formed or they are organically formed. So in this case, the minerals crystallize out of solution to become rock. For example, limestone, dolomite limestone, which is chemically formed. Or they are formed from remains of plants and animals, for example, coal. So such non-clastic sedimentary rocks, which are organically formed, could also be referred to as the biogenic rocks. So referred to as biogenic rocks. So we have said that the non-clastic ones are chemically formed. They are chemically formed, or they are organically formed. So examples may include, you can see here, there is a limestone. Limestone, this is chemically formed. Then we have what? We then have coal. So we were saying that the examples of these rocks are the limestone rocks, which are chemically formed. You can see they are there. Then we also have, this is coal, which is a biogenic rock, organically formed. So they are non-clastic, they don't have those particles. So otherwise, we have said the categories are the clastic and the non-clastic rocks. Because at times the question may be distinguished between clastic and non-clastic sedimentary rocks. Part A, then part B, discuss the importance of sedimentary rocks to man in East Africa. Now the categories, we've looked at the 2 broad categories. Now the types. Already we have said, we have talked about the mechanically formed ones, the organically formed, chemically formed. because this is not pretty new. In your O level, you did something about rocks, and you hint on this. Here it is just that you may need to go into slight more details. This is not something new. Now, the types of sedimentary rocks. The formation of sedimentary rocks can be classified according to three types. And these include mechanically formed rocks, organically formed rocks, and chemically formed rocks. Organically, chemically, and mechanically formed rocks. These are the three. Now, when we're defining sedimentary rocks, we had looked at the broad definition was basically about the mechanical formation of the rocks. So these are the mechanically formed rocks. Mechanically formed or physically formed sedimentary rocks result from the breakdown of already existing rocks into valid textures. I mean, it's supposed to be varied, not even valid. Yeah, it's supposed to be varied. Varied textures to form varied rock types. Okay. And all these depend on the agent of erosion. You know, earlier on we had said that these rocks may be weathered and they are eroded and the material is transported. These agents of erosion cause transportation and deposition of the eroded materials. So these agents are running water. First of all, there's running water. Then we also have wind. We have glaciers, that is ice. We have the glaciers. Then we have waves, which may transport and deposit marine deposits, marine silt. So materials eroded, transported, and then finally deposited. So these deposited materials accumulate and become compact. They accumulate and become compact. And as time goes on or elapses, the deposited materials are cemented and consolidated and then turn into a mass of rock called mechanically formed sedimentary rocks. Just as we had said from the earlier definition, it was mainly based on the mechanical formation of sedimentary rocks. So mechanically formed sedimentary rocks. Then that is from the rivers. So river deposition creates alluvial soils. These alluvium may be compacted. The alluvium of different stages may be compacted to form what? Mechanical sedimentary rocks. Then ice or glaciers. Create till or moraine. Till is unconsolidated material deposited directly by ice or by glaciers. Till. Then wind deposits loose. So loose are deposits by what? By wind erosion. Wind erodes and then deposits the material. Material is referred to as loose. and marine or wave action creates marine deposits. So the agents, wave erosion, wind erosion, glacier erosion, river or running water erosion. Now, examples of resulting rocks may include sandstone, mudstone, claystone, shell, gravel, among others. So these could be some of the examples of, like the others we say, like those ones like breccia, we saw them. All those are what? Marine. I mean, they are mechanically formed sedimentary rocks. So Matovu Jacob asking.
Master, Master, it's like I just wanted you to kindly explain for us about that shell. Shell, as in some of us we may not be knowing about that shell. So kindly we ask as in to explain for us about that shell, as in the way.
Shell, this other shell. Okay, someone was asking, is it for this slide or this other one? But I think we can we'll shout to get the information later on. Yeah, I explain how shell is formed. It is formed from claystone. Now, when claystone has been put under pressure, it turns into what? Shell. That's why there are some people who would think that shell is a metamorphic rock, but it is not. Shell is a sedimentary rock. Shell has not changed to an extent the shell, I mean clay is compressed. Clay is compressed under pressure, though the pressure is quite low. So it turns into what is known as a shell. Claystone and the shell are similar, except that the shell is harder than the claystone, because it's more compressed as a result of pressure. But they are both sedimentary rocks. But then now, when under intense pressure, if claystone is compressed seriously, then it turns into slate. Slate is a low, I mean, is a what? Is a metamorphic rock now. Slate is a metamorphic rock. Low grades metamorphic rocks. Slate is one of the lowest grade metamorphic rocks. So those who think that the shell could have changed from claystone, I mean, it could have turned, clay could have turned into shell, and the shell is metamorphic. No, that is not. It has not changed enough. It is still what? Sedimentary. Okay, so here's some diagram. So this is someone is asking about lithification. Lithification is what? The cementing, process of cementing of the different layers of rock together to create sedimentary rocks. That is lithification. So this diagram illustrates mechanical formation of sedimentary rocks. Mechanical formation of sedimentary rocks. Here, as you have seen, weathering takes place. Weathering weakens rocks physically and chemically. So then the materials are then transported by what? By the agents of erosion. So erosion splits the weakened rocks through water. Then here there are transportation of eroded materials, then deposition of the transported material takes place in the low-lying area. Then after that, they are compressed under their own weight to form sedimentary rocks. So saying that sedimentary rocks after deposition, consolidation, compaction, and cementation has taken place in the low-lying areas. Okay, now we may go to what are referred to as the organically formed sedimentary rocks. What does organic mean? Organic, when we're talking of organic, we're referring to some organisms. So you can say these rocks are a result of cementation and compaction of remains of once living plants and animals, mainly plants, of course. So coal is an example of organically formed rocks resulting from the decomposition of plant organisms. So in the prehistoric times, there could have been plants which were especially where there were heavily forested areas. So the plants, after dying, they were their parts. Their parts were compressed together, were piled up, heaped together, and compressed under their own weight to form organic sedimentary rocks, such as coal. Then we also have some organically formed sedimentary rocks like coral limestone. So coral limestone. Coral limestone is formed from the skeletons of coral polyps. So coral polyps are organisms. Those who could have gone to places like in the East African coast could have seen live corals. So those coral polyps die, then their bodies, I mean their skeletons are deposited. They're piled up upon each other, or accretion takes place, then compressed under their own weight to give rise to sedimentary rocks, organically formed sedimentary rocks. So there was someone using an iPhone had put up the hand. So it's better you rename your what? Yourself. What is meant by consolidation? Consolidation is becoming compact, not loose. When talk of things which are loose, loose aggregates, those are not consolidated. Consolidation
Mr.
is
Sir, in the
together.
chat room, we have some questions there. You can check there.
Yes, that's why I was answering what was saying that, what do you mean by consolidation? Yeah, I'd seen it. I was trying to explain between what, and I mean explain what is meant by consolidation. Then there's someone is saying that we can't hear you, but possibly it is your what? Could be the problem of your device or the headset. Then is coral, or is it coral or coal? Because I'm confused. Now someone thinks coral is the same as coral. Adjust your devices. Okay, so yeah. Usually, like when you are talking of consolidation, consolidation is something which is not fragmented. Normally, when we talk of land fragmentation, those are small loose pieces of art or flocks. Then consolidation is amalgamating them together to have one solid thing. Now, one who was talking of difference between coal and peat. Yeah, peat. Peat is also organic, but it is not what? Coal. It is not coal. Peat may be soft material. See, some of these may not necessarily be what? Technical geographical terms. Some of these are what? They are English words. So even from your dictionaries, you can find out what is meant by what? Peat, and what is meant by coal. Then the one who was saying that is it coal or coal? Yes, they are different things. Coal has to do with what? With some marine organisms. Coral is marine organisms in the category of animals. While coal is an organically formed sedimentary rock, and is used as a source of energy. But because I'm confused, coral polyps, yes. Coral polyps are the organisms which make up what? Coral rocks. Those coral rocks, the coral rocks are what we call coral limestone. They're called coral limestone. Coal is not limestone, they're different. Coal is different from coral. Other examples are so now someone is telling us other examples are ignite and ground coal. Okay, I think you wanted to say lignite. Lignite is also a type of what? Coal. We also have anthracite. Anthracite is another type of coal. And we also have brown coal. Anthracite, coking coal, lignite, and brown coal. Those examples of what? Organically formed sedimentary rocks. So is brown coal and lignite coal examples of organically? Yes, they are all types of coal. All types of coal are what? Organically formed sedimentary rocks. So lignite is Li. Okay. Peat, peat is organically formed. Yes, though soft, and when dried, it can be used as a source of what? Energy. Organically formed sedimentary rocks. Can go to the next slide. Okay, there's someone who has said. Someone is saying that I think peat is an example of intrazonal soil. Yes, but the soils are related to rocks. Okay, while coal are marine organism. Coal, no. You unless you wanted to say corals are marine organisms, not coal. So yes, someone who was that one putting up the hand. Mumbere. Before we may go any further. An area where coal is found. Yeah, these ones we shall see. Ruhuhu Valley in southern Tanzania is an area where we may find coal in East Africa. Otherwise, in the Ruhr, in the industrial, in the Ruhr region is well known for what coal. And there's so many places where coal is mined, as we have studied in this geography of Africa, North America, and the Rhinelands, and also China. Yes, Ruhr Valley in Tanzania. Okay, now organically formed sedimentary rocks. Let us now go to the other cases. Okay, so when plants are covered by some overlying materials, temperature and pressure rise. Temperature and pressure rise. And these plants gradually turn into changed hard materials, e.g. coal. Examples of coal include lignite coal, anthracite coal, and bituminous coal. Also coking coal, as well as brown coal. So here's an image of that coal. Image of coal. The other one we had also seen earlier on when we were looking at the non-clastic rocks. Then now with these marine organisms. Another example of organically formed rocks are coral reefs, or generally coral rocks. Okay, the coral reefs are rock platforms. Another example of organically formed rocks are coral reefs, or when we say coral rocks, because the coral rocks are the ones which make up the coral reefs. The coral reef is a rock platform, which are formed from the skeletons of tiny marine sea animals, namely polyps. So coral polyps make up the what? The coral rocks, which are organically formed. The skeletons of those animals are made up of calcium carbonate. They're made up of calcium carbonate, so the skeletons, when they are compressed, when they are piled together, compressed, and then crushed into what? Into solid rock, they end up with what we call coral limestone, because the materials, the skeletons are basically of what? Of limestone forming material known as calcium carbonate. So in your senior 3 or 4, when you are dealing with the corals or coral reefs, I think you must have studied something related to this. This is a reminder just here. So we're talking of what? Another example of organically formed sedimentary rocks. We talked of coral. Now we're looking at what? The corals, coral rocks. So coral reefs eventually produce limestone rocks. Yes. So the coral rocks make up what? And have limestone in them. That's why at times they're called coral limestone. And they're being used for making this limestone we use as a building material, construction material. For example, in Mombasa at Bamburi, the Bamburi cement is basically from coral limestone, while Hima, Toro cement, those ones are mainly what? From dolomite limestone, which is organically formed. So limestone may either be chemically formed, like the ones in Hima and in Tororo, the carbonatite limestone. Then there are those ones, limestone may also be from what? Corals, known as coral limestone. So when these organisms die, the skeletons accumulate on the continental shelf, where they are gradually cemented and also compacted by successive weight and solution secreted by other organisms, notably echinodams. So echinodams act as a cementing what? Ingredient, cementing ingredient. So they're cemented together, compacted and cemented together. So gradually, the loose materials turn into more consolidated, compact. So something which is not loose is consolidated. So one was asking about what consolidation means. It is the opposite of what loosely lying material. Turn into more consolidated, compact, massive hard rocks, leading to formation of coral reefs. So the coral reefs are the rock platforms. The coral reefs are made up of coral rocks. And this is an example of an example of an organically formed sedimentary rock. Yeah. Someone was asking that I should repeat about consolidation. I said consolidation means converting from loose material to massive rocks. Conversion from loose particles to massive rocks. That is what meant by consolidation. So consolidated rock is rock which is not made of loose particles. So loose particles, when they are joined, amalgamated together, we say they are being consolidated. So for more about consolidation, you can also check your dictionaries, see what consolidation may refer to. And in this case, they have many meanings. The more appropriate meaning relating to what? To rocks is also given in the dictionaries. Someone has asked about some examples of polyps. Yeah, unless you may see them, but there are various types. Some are as if with these several branches, others are mushroom shaped and the like. So those ones, if you are to look at them, they are there. But after this, there were a time when we shall look at corals. You look at the pictures and examples of what? Coral reefs. So is there a difference between echinodams and algae? Algae are what? Yes, there may be the difference. Yeah. So algae, I think from your biology, you may know what they are. That's why I'm saying that some of these things, they may not necessarily be geographical terms. Algae, in water, that greenish thing, it cannot help in what? In cementing. But there are also echinodams, which are what? There are some water organisms that may secrete what? Materials which can cement rocks together. Algae may not be the same as what? Echinodam. Okay. Now this is an example of what? Coral rocks. These are coral rocks. This image was taken from Mombasa. This image was taken from Mombasa. These are coral rocks. Coral rocks. You can see they may not have been refined because you know the skeletons of the corals. Even among these ones, if you could draw closer, you can see some particles of what? Of skeletons of the polyps which have not been crushed to form the rock. Then they are lying on this one is the coral reef. This is a coral reef, or where the rocks are on, made of such material. These are the coral reefs. This is what they call a fringing reef. Fringing reef. You can see a coral reefs. These are coral made of coral platforms. It's a coral platform. Landform made of coral rocks. A fringing reef attached to the what? The sea. This is also at a place in Mombasa. Yes. Someone is saying that should I think that when these animals die, they are directly accumulated, or they should be transported before accumulation? Yeah, then they may be transported before what? Accumulation, or if they die at a point where they may not be transported, yeah, that's where they'll remain. They may not necessarily be what? Transported. But usually waves transport them. So are coral rocks found in Uganda? No, there are no coral rocks in Uganda. The coral rocks are along the East African coast. So the types of coral reefs, this will be another topic, whether you have fringing reefs, barrier reefs, and atolls. Is it a must that coral reefs have to be near water bodies? Yes, coral reefs have to be close to tropical marine water bodies. Tropical marine water bodies, not any water body. The water body must be tropical, where there are warm ocean currents, and it must be marine, salty waters, not fresh waters. Coral reefs are marine because coral reefs are made from marine organisms, so they cannot find them in a place where there are no marine waters. So the coral reefs only located along the coastal areas? Yes, they are located along coastal areas. Like now, like in East Africa, they're along the East African coast, because the Indian Ocean has marine waters, and it is within the tropics, which offers conditions for the formation of corals. Okay, now chemically formed rocks. We have the chemically formed rocks, sedimentary rocks. These are rocks which result from the chemical precipitation and evaporation of salt solutions in hot tropical regions. When water evaporates, the beds of salt, known as evaporites, are left behind as a residue or deposit which dries up. Which dries up, get compact, cemented, and consolidated, and hard rock, e.g. chemically formed sediment rocks, i.e. chemically formed sediment rocks. Examples include dolomite, limestone, rock salt, among others. So chemically formed sedimentary rocks. So when we talk of something precipitating, so in this case, it comes from the word precipitate. So when something turns into somehow solid, we say it as precipitated, especially after evaporation has taken place, like when there is very salty water and the water evaporates, it leaves behind a precipitate of what? Of salt. So when I talk of chemical precipitation, that means what? Material turning into solid after evaporation of the what? After evaporation of the water. Not the precipitation like in form of what? Of rain, snow, sleet, not that. This is what we refer to as a precipitate. It's like also in a lab. In a lab, when you mix certain chemicals, you find they coagulate or turn into a kind of precipitate. So that is what we are referring to. So now you can see here, this is some limestone. This is a limestone rock, example of limestone rock, dolomite limestone. Then also dolomite, you can see here limestone. Limestone, these are images for those who may not have seen. Some of you have visited Hima, you have visited Tororo, where they mine what? Limestone for making cement. Okay, so after this, we are going to look at now the last type of rocks, which are the metamorphic rocks. Are these chemically formed rocks found in Uganda? Yes, the only chemically formed rocks like limestone, the ones in Uganda are what? They are chemically formed. We have Tororo rock, there is the limestone. Also Hima, they mine limestone. So meaning that the limestone, which is mined for making cement from Hima and also from Tororo, and also there's some limestone we get from Karamoja, then also there's limestone in Kisoro. These ones are in Uganda. So, but in Uganda, we don't have coral limestone. We don't have organically formed limestone. There's no coral limestone. Yeah, someone was asking about chemical precipitation. Yeah, chemical precipitation means some kind of solution turning into a precipitate. After evaporation has taken place. Because it is a solution, so that is where the word chemical may come in. So now later on, after it has evaporated, a precipitate, it precipitates. A precipitate is formed. That is what we refer to as chemical precipitation. Someone is asking, is Mohoki and Kasese not a mining site for limestone? Yes, it is. How about the Sukuru Hills? Yes, also that is in Tororo. Sukuru Hills. So limestone. Okay, now we are now going to look at what? Sedimentary. Is limestone formed within water or on the ground? So it is found on the ground, yeah, basically on the ground. Metamorphic rocks. Metamorphism. Metamorphose. If you look at the dictionary, what does metamorphism mean? Means to change. Like when talk of the metamorphosis of lava, may turn from a lava pupa then into something else. Yeah, that is biology. These are really the same thing. So when we talk of metamorphic rocks, these are changed rocks. And we should get to know what changes these rocks. What changes these rocks? These rocks are basically formed, are basically changed as a result of two major factors. That is heat. Heat changes the rocks. Usually heat changes anything. You may burn something and it does what? It changes. So change due to heat or change due to pressure. Intense pressure may also change something. iPhone, is it an iPhone? Why I will tell you from your devices, you can rename yourself. So you can ask. Okay.
I was asking, sir.
What is
like
your name?
My name is Robert Freeman Arinitwe.
Arinitwe, okay, you can.
I was asking,
so
like,
when we see iPhone, we know that is Arinitwe. Okay, ask.
Like, describe the process which is the formation of sedimentary rocks. How do you approach that question?
What?
Like when they ask, like, describe the process which is the formation of sedimentary rocks.
Yeah, but that is exactly what we have been looking at here.
I was just asking the approach.
The approach.
Yeah.
Describe the process of the formation of the sedimentary rocks. Okay. You first of all, you define what is meant by sedimentary rocks.
Yes.
Then you give the characteristics. And afterwards, you give the characteristics of what? Sedimentary rocks. Then if there are any conditions, the conditions may not be okay. You may then give some few conditions, like what? Like there should be the weathering of rocks and also agents of erosion and transportation. Those conditions. Then you describe how each of those rocks are formed. You first of all say that these sedimentary rocks can either be formed mechanically, chemically, or organically. Then you describe the various ways in which the mechanical sedimentary rocks are formed, chemical ones are formed, and so on. Then you end it just as the way we have been doing. But the first thing is to define and explain what sedimentary rocks are, then their characteristics, then explaining how they come about. I think it is clear.
Like some, like doesn't it need to define where they are located in the answers you are giving? Like when you are giving like sedimentary rocks, they are organically formed, where they are located?
No, because now with all these questions, in most cases, when you give a point, usually what we normally emphasize, at least in geography, generally, even in some subjects like economics, you may give the point, you explain it, and you back it up with what? An example. So when you give those examples, those examples must be integrated with the what? With the explanation or the points. Because in most cases we say that identification of the point, explanation of the point, then illustration also of the points, because you have seen some of the diagrams you have been giving there. You also need to illustrate, then you give us some examples to back up. So that's when they'll know that you're what? You're a knowledgeable person. So you have managed to identify.
Yes.
Then you have also managed to explain correctly.
Yeah.
Then you have also managed to illustrate diagrammatically, give some diagrammatical diagram, and some diagrammatical illustration. Then you have also been able to cite examples. Examples show that you have knowledge about your region or your country, especially you are knowledgeable. Otherwise, one would be, you can be having limestone in your village.
Like some, I was saying that too. I'm sorry for interruption. I was saying that like when you give an example like limestone found in Kasese, like coral reefs in Ruhuhu, Tanzania, is it necessary?
Yes, yeah.
Okay,
It is necessary. You give the example and where they are formed, because limestone may be located anywhere in the world, but now in your area, the question could possibly be referring to East Africa. Even if it's not East Africa, but at least you have to give examples where those rocks are found.
Found, yeah.
Yes, you have to give them, because it will be funny to say that limestone in Uganda. Does that sound funny? You rather say limestone at Hima, at Hima
Kasese district.
in Kasese, yeah, something like that.
Yeah,
Excuse me, sir.
Yes, okay. Is it in Nangons? Okay.
Excuse me, sir.
Yes, you're excused. You're excused. You may ask.
When I'm giving, like, when they ask me distinguish between igneous rocks and sedimentary rocks, and I give the definitions, is it necessary to also give the categories of sedimentary and igneous rocks?
Yes, you should, because when they say distinguish between igneous and sedimentary rocks, yeah, you have first of all to show what they are, then how they are done, how they are formed, then they are the what, they are the examples. Because now, like for the igneous rocks, you must show that they are formed as a result of what the formation may depend on the rate of cooling of the magma. Then on the other hand, they may also be determined by the chemical composition. All of those should be given, because now, like some question like that, you may find that distinguish between igneous rocks and sedimentary rocks. Like was it the ones which came this year, 2020? There was about the metamorphic rocks and the igneous rocks, whereby each was, you could see it was about 15 marks. So meaning that for the distinguishing features of igneous rocks possibly are around 7 to 8 marks, and also the distinguishing features of the sediment rocks about 7 to 8 marks also. So when you just merely define and you don't add some kind of description, can you really get those 7 marks or 8? Okay. Michael, Sparks.
Master.
Yes.
Thank you, sir. I was just asking, what if they say that account for the formation of the major rocks in the, let's say that in the world? How can you tackle that question? Can you give the igneous rocks and you leave the metamorphic, or you give both of them?
You give all the 3 types of rocks. So when they say account for the formation of rocks, account for the formation of the different types of rocks, account for the formation of different types of rocks. Yeah, there you have got to first of all, you define what a rock is. You may briefly give the physical attributes or chemical attributes of rocks. Then you give the what? You identify those rocks, igneous rocks. You give the conditions or the processes under which they are formed. Also the same with the sedimentary rocks, the processes under which they are formed, and also with the metamorphic rocks, the processes under which they are formed. You deal with all that. So that will be a very long word question, but then some of the things we need to cut them short. Otherwise, you have seen igneous rocks. We
Master,
have by.
Sir.
Yes.
Sir.
I want to.
Excuse me, sir.
Yes, you're excused.
Yeah, about you told us about the distinguish as in like of the two. To my knowledge about what the teacher told us at school, they told us that you first give the introduction, their formation. Okay, after giving their formation, then after you go to the body, you give the as in the characteristics of each of the two. Then if they tell you as in to draw the illustration, then you give the illustrations about the two. That's what I know. I don't know whether it's correct or I just wanted to know about.
Yes, it is. Yeah, it is correct. So definition, yeah, is okay. Then the what? The characteristics, mode of formation, mode of formation, then diagram and examples. Yeah. Those are the areas. Now you can find that now, like for the igneous rocks, one who defines that may be 1 mark. Then one who gives some characteristics, it may not require all the characteristics, the major characteristics could be given. Yeah? No, like about some 2 or 3 characteristics is enough, which are distinctive. And unless it is a question of its own, that's when we give all the what? The characteristics. So you will give some characteristics about some, in the mind of one who is marking, about some 2 marks there. Then
the examples?
The mode of formation, the process of formation, also some 2 marks there. Then the examples, some 1 mark there. If there's a need for illustration, also 1 mark. Now you come to, don't you see that now you come to around 8 marks.
Yeah.
Also for the other rock, the other type of the rock, you also give the what? The same.
Excuse me, teacher.
Yes.
Supposing you asked to explain the relationship between rock hardness and slope formation in East Africa, how can I attack that question?
But have you already done something about a slope formation?
Not yet.
Because yes, you need you first, because that's why I'm saying some of these rocks, some of these questions are summative. They relate one topic to what? To the other. So now that will need me to teach you what slope formation first, then you see how to relate it to what? To the rock hardness or the rock structure. It's the same one. One was saying that the influence of igneous rocks on formation of landforms. One who has not done volcanistic, of course, you cannot be able to answer that question well. Someone was saying, teacher, is it correct to give the outline of the processes that lead to formation of sedimentary rocks, or it's long? When you are distinguishing, yeah, you can outline, okay, the processes. But when the question says accounting for the formation of sedimentary rocks, then there you give the what? You may not merely outline. Okay. Yes, yeah. So teacher, while distinguishing, we handle each type as a whole. Then the other, yes, yeah. It's better you start with the sedimentary. I mean, you start with igneous. Then you say while, or on the other hand, or whereas, there you are distinguishing. Then you talk about the other one as a whole. Okay, so now I think let us go to sedimentary rocks, though I think we're remaining with about some 10, I mean some 10 to 15 minutes. Now, metamorphic rocks. Are there still some more pertinent issues concerning the sedimentary rocks, so that we can then go to these ones? Because in the chat, someone is saying, teacher, you mean we should first describe one? Yes, yeah, you deal with one first. Then and then the other one, when you are describing. I mean, when you are distinguishing.
Yeah.
Then loose and alluvium are also sedimentary. Yes, they are mechanically they lead to the formation of mechanical sedimentary rocks when they harden, the loose and alluvium, as I said. Good. Metamorphism, that we are talking of changing rocks. Metamorphism means to change. That time we were saying that why may rocks change? Why may rocks change? Rocks change with temperature and pressure. So the temperature now here, it means high or hot temperatures. Hot temperatures may change rocks, and intense pressure may also change rocks. So normally when we are paraphrasing the metamorphic rocks, we just said changed rocks, the changed rocks. So changing due to hot temperatures or pressure. So, and these changes usually takes place deep in the earth, in the earth's crust, in the crust of earth. That's where the changes may take place. So, what may make rocks to change? Heating. So temperature. So when we talk of heating, the what pertains to heating is known as thermal. Thermal, when talk of thermal electricity, that is a generation of electricity as a result of heating of coal, or the heating of what? Petroleum. Heating water to generate steam power. So heating, thermal electricity. So this one is also when talk of thermal metamorphism, that is heat changing the rocks. Then pressure, intense pressure. That is what we generally refer to as dynamism, dynamic metamorphism. Intense pressure changes the rocks. But what we should note is that with the heating tends to be localized. Thermal metamorphism tends to be localized. It affects a small area, while pressure, but now you can ask ourselves, what brings about that pressure? The pressure is brought about by tectonic processes such as faulting, folding, warping. Those processes may subject the crust rocks to pressure. A lot of pressure, and in the process they can change. So this is the pressure, which is also be referred to as a dynamic, affects a very large area. That's why at times it is called a regional metamorphism. Regional or dynamic metamorphism affects a very large area. But the thermal one is only in the places where there is what? There's heat, and more especially volcanic heat. So they usually take place in the Earth's crust. Master, what is to localize? More explanation on the thermal contact. Then also, it can be both as a result of heat and pressure. So heat and pressure combined can also change rocks. So the combination of the two, of thermal and the dynamism, now gets us what we refer to as thermodynamic metamorphism. Thermodynamic metamorphism, heat and pressure, changing the rocks. Thermal due to heat, pressure is dynamism. So we can continue to for some detail. So we say that thermal metamorphism. Thermal metamorphism is also known as contact metamorphism, because the rocks have got to be in contact with a source of heat, which is usually magma lying close. So it is those areas which are lying close to the magma, the crustal rocks are the ones which are heated and they change. Usually, you have ever seen people laying bricks. People get clay, then they use their tools for shaping them. Then later on they dry them. After drying them, they fire them. So to make what? The brick red. The bricks. So that is what is called what? Thermal metamorphism. So the clay has been changed. The clay has been heated, it has been fired, and has changed into a different what? Substance. So a brick that has been burnt is a form of metamorphic rock. It is not the same as the other clay material which was shaped and then dried. So thermal or contact metamorphism. Rocks are heated by nearby magma. We've said this affects on a small scale. Doesn't affect on a what? Large scale. The thermal or the contact metamorphism. Sometimes we say thermal metamorphism. So we're saying that increased temperature changes the composition of the rock. Increased temperature changes the composition of the rock. Old minerals are changed into what? New ones. They are turned. The minerals are changed. Physical and chemical, they're changed. So the hot temperature changes the composition of the rocks. You can now see here, hornfels. Here, this picture, this is a hornfels. Is a fine-grained.
The other stuff that I sent you. The other stuff that I sent you for
what? So there is a Matov, you're saying you sent me some stuff.
No, master.
Now, hornfels is a fine-grained, non-foliated metamorphic rock. We shall see what is meant by what? Foliated. The lines. Yeah, that is the foliation. We shall see it before we end. So you may not ask. This is non-foliated because there are no lines here. The foliations are the what? Lines across, showing signs of pressure. So this one is not as the result of pressure. That's why it is non-foliated. There are no bands, non-banded. So hornfels for the metamorphic rocks produced by contact metamorphism. Thermal metamorphism, an example of thermal metamorphism product is what? Is hornfels. So here you can see there's hot magma. So the rocks which are close to that hot magma are the ones which are metamorphosed by contact or by heating. So that is what it is. Is due to heat. So there's someone who's complaining that has run out of data. Okay. So now, then there is also dynamic metamorphism, or we also call it regional metamorphism. Dynamic or regional metamorphism. This affects a large area and results from plate tectonics, earth movements, and weight of overlying rocks. So tectonism and weight of overlying rocks exerts pressure on the rocks, which makes them to change, So the rocks are changed due to pressure. So the pressure which results from tectonism, plate tectonism, it could be faulting, it could be folding, it could be warping, exerting pressure. So that's why we say it affects a very wide area, affects a very large area. So when we talk of pressure, we can see some diagrams are here. The plates, tectonic plates are moving towards each other, moving away from each other. Then the crust rocks are subjected to what? Pressure, which eventually changes the rocks. So that is a dynamic metamorphism. Dynamic. Yeah, the one with some baby around. Who is that one? That is Matov.
There's a lot of feedback, sir.
Yeah, and he's Matov. I think let us see if we can mute him. Otherwise, okay. So an example of dynamic metamorphism. So now here. So someone earlier on you had asked about shell. Sometime when we started asking about shell, you can see here. So this is clay. Clay under pressure turns into shell. Then later on under extreme pressure turns into what? Slate. So slate is what? Is metamorphic. But this shell is still in transition. It is still a what? A sedimentary rock. Clay is a sedimentary, shell is still sedimentary, but you can see this one has been compacted and hardened by what? Pressure. And now by this one now you can now see the molecules, very compact and hard. So we may now so the slate, you can see this is because slate results basically from what? From pressure. So clay and if clay is heated, yeah, then it may turn into something else. But with pressure, may turn into slate, which is metamorphic rock. Then lastly, we have thermodynamic metamorphism. Thermodynamic, that is both heat and pressure. Thermodynamic. Both heat and pressure combined results into change of rocks. Both heat and pressure results into the change of rocks. This affects a fairly large area. So both heat and pressure, may affect a fairly large area. So now let us look at that. The foliations now. Saying that we'll look at the characteristics in general. What is meant by what? Foliations. Metamorphic rocks can be foliated, i.e. showing layers or bands of minerals. So the layers or bands of what? Minerals. In those layers are of different what? Colors. Stripes. E.g. gneiss. Or they can be non-foliated. They can be foliated, for example, gneiss, or they can be non-foliated. For example, marble. Marble is non-foliated. So most of those which are non-foliated are as a result of thermal metamorphism. But many of those which are as a result of dynamic metamorphism, they tend to be foliated. These are metamorphic rocks. So here we have marble. Marble is here. We have, this is what? Gneiss. Gneiss. I think you can now see these lines of different color showing different what? Mineral characteristics. So this is what we call foliated. These are the foliations, foliated rocks. So gneiss is a foliated what? Metamorphic rock. While marble is a non-foliated metamorphic rock. Hornfield, which we saw earlier on, was non-foliated. Non-foliated. Someone is saying that can slate turn back to clay if put under high pressure? No, now slate is already at a what is already changed. Slate can only now change into what? Igneous rocks, possibly, or a higher grade metamorphic rock. Slate cannot come back to clay. Slate can go to a higher grade metamorphic rock. If it is heated further, I mean, if it is put under higher pressure, it may turn into another thing, but not that it can turn back to clay. Or with heat, it can be turned into what? Yeah, with extreme heat, yeah, it can turn into some other form of rock. If it is even melted, if the heat is so much that it can melt, it turns into what? It may turn into igneous rock. What is the use of slate? Slate can be used for what? For even for construction. Like these are rocks for construction and the other uses. So you may find the other uses. You can Google. You can check from what the dictionary. So the uses of what? Slate, but mainly for building and construction. So foliated with this band. This is known as banded or foliated, showing that it was compressed. It was compressed by intense pressure. Joshua Johnson, I'm saying Johnson, your hand is up. You may ask. Okay.
Master, can coal turn into graphite like when exposed to heat and pressure?
Yes. Yeah. Coal. I think you can see here. Are you seeing this? This is somewhere the last thing after limestone. After limestone, there is a coal. Thermodynamism turns into what? Graphite. So this is a summary of metamorphic rock formation. The original rock, if it is granite, heat and pressure, it becomes gneiss. Sandstone, through pressure turns into what? Quartzite. Clay, through pressure, turns into what? Slate. Shell, through pressure, may turn into schist. So schist is a medium grade, is what we may refer to as a medium grade metamorphic rock. Medium grade metamorphic rock. Slate is a low grade metamorphic rock, because with the schist that was pressure was much higher than the one than the pressure which could turn shell into what? Slate. So limestone, Thermo Metamorphism, marble. Limestone turns into marble by heat. Then coal by heat and pressure turns into what? Graphite. So that one there is some table showing summary of what? Of rocks, examples of rocks. Difference between graphite and granite. Granite is a plutonic sedimentary rock. Granite is a plutonic igneous rock. Is a deep-seated rock and made up of fine, coarse grains. Huge or coarse grain because the rate of cooling during the formation was very low. While graphite is a metamorphic rock. Graphite is a metamorphic rock from an organic sedimentary rock. When an organic sedimentary rock like coal is put under heat and pressure, it turns into graphite. So graphite is not the same as what? Granite. Okay. So I think let us see how we can summarize with the what, with the characteristics here. Then I think then that's where it ends. So because it's already past 4, someone sent a message there that she was going for a literature lesson. Some say they have run out of what? Of data. So let us just see a characteristic of metamorphic rocks. The structure is usually changed. So they are changed rocks. Generally, they're physical and chemically changed rocks. 2, they may be foliated or banded, such as gneiss, phyllite, schist, and slate. They may be what? Foliated. Then, or they may also be non-what? Foliated, okay? And thirdly, they may be recrystallized because because of the heat and pressure, the crystals may change. The nature of the crystals may change, and recleavaged. If you can remember what we talked of rock cleavage, these ones are recleavaged. The cleavage they gain. The breaking of, the weak bonding points are rearranged or changed. Then they are hard and difficult to weather on the road. That is, they are compact and resistant. They are stable rocks. The structure does not easily change. Then they rarely contain what? Fossils. They rarely contain fossils, and they easily react with acids. So those are some of the what? The characteristics of sedimentary rocks. Now the last bit here is foliated metamorphic rocks. Foliated metamorphic rocks such as gneiss, phyllite, schist, and slate have a layered or banded appearance that is produced by exposure to heat and directed pressure. So heat and directed pressure cause foliations such as gneiss, phyllite, schist, and slate. Then the non, yes?
When I'm seeing the characteristics you are talking about.
Okay, let me finish this one, then I will ask. It is in the what, in the other slide. I will move to another slide. So non-foliated metamorphic rocks such as hornfels, marble, quartzite, and novaculite do not have layered or banded appearance. So we'll say that rocks, metamorphic rocks may be foliated or non-foliated. Foliated ones include the gneiss, phyllite, schist, and slate. Non-foliated ones, quartzite, hornfels, marble, novaculite, and so on. So that is it. So these are the characteristics. Our friend was asking for them. So the characteristics of metamorphic rocks, those are the ones. I think this is where we are stopping now. We are stopping here because we're already past the time. And then a number of people have already dropped off now. Okay, so at least today we have covered much of, we have dealt with this we are finished now the types of what? Rocks. So what we're remaining is something about the rock cycle, which is small, and also just the importance of rocks, and possibly some questions to do what? To answer. At the end there, I sorted out some questions which you need to do what? To answer. Otherwise, this is about the rocks. And someone may be saying, okay, so someone was asking about my contact, that your contact. Okay, let me just put it on the chat. So this is a so that is 0772447802. That's a WhatsApp line, and the other WhatsApp line 275-604-8863. Okay, so I think let us see, we have overshot. So now, if there are any questions, you can ask. Otherwise, I may also